Can you describe your current research and how it connects with AI Leaf? The first one is related more on the forestry side, and it is integrating remote sensing knowledge and knowledge from the forestry domain with machine learning and computer vision in order to better predict above ground biomass and get better carbon estimates. So, all of my research is kind of in the field of machine learning, artificial intelligence, and computer vision. The forestry project in particular, I've been working with Chad Babcock. Yeah, one of the cool things that we're doing is for satellite imagery. Obviously, it's very widespread, it's readily available, so it's a really great data source to use, but there's a lot of challenges with satellite imagery that aren't really addressed in traditional computer vision domains. So, one of them would be that the dates that imagery is available for certain places is going to be different depending on what your geographic location is. And sometimes the satellite passed through an area, but there was a lot of cloud cover that day, or there was a lot of noise in the image, so you don't have good readings for that day. So you have all these time series with different points. How are you going to get a good representation for them? So I've been using a phenology model developed by Chad to try to characterize the overall growth of above ground biomass in a forest over a year and then pass that through a computer vision model. And we've been experimenting with some really like state of the art computer vision models and geographic foundation models to produce better overall carbon estimates. So that's one project that I'm working on. And then the other one is a soil science project that I'm collaborating on with Nick Jelinski and also with my lab mate Ejin Lin, using state of the art computer vision models again to develop models that can predict soil properties such as permafrost presence or absence or the soil taxonomic class. So that one's actually really cool. So we had like a few milestones, I guess, we reached this summer. The traditional model that they use for is random forest. We were trying to take the computer vision models and kind of like adapt them for this task. So we introduced a module in the model called a neural implicit function that can help model the soil properties more continuously and more accurately. The other thing that we did is so Alaska is a very, very understudied region, and that's our region of study. And permafrost, it's really important because it's melting and it's destroying infrastructure. It's very important to keep track of it. And there's no high resolution map at the 10 meter per pixel scale. So we've generated the first 10 meter per pixel maps for certain soil properties like near surface permafrost presence, like the soil taxonomic classification. This is also like not possible without Nick because he is the one who like collected all the data and sort of put everything together from previous literature, which also that database hadn't been created yet. So him making that kind of like enabled us to run a really like computational, heavy computation model. And someone actually reached out to us, like a community that's they're worried about permafrost melt and they want to see like what areas they should potentially be surveying. Since there's just no maps out there, they asked us if they could use the ones that we generated. We were like, these are like kind of preliminary. There's going to be around two of results, but for them, even, having that information is better than just having nothing at all to go off of. So that was actually really, really cool to just have someone ask us to use it. One thing they have to do is if your like housing or your buildings are on areas that are very high risk for permafrost melt, you have to survey other areas, that you might want to move your infrastructure to. It's difficult to predict climate change, the development of wildfires in that region. It can make the conditions shift very rapidly. Yeah, hopefully you're able to like give them some hints as to, where might be like a good area. Yeah. So what are some of the most promising use cases of AI in sustainable agriculture? The development of these really advanced computer vision models and also online computer vision models seem like really exciting use cases to me. A lot of those online models can be used for unmanned aerial vehicles like drones flying over fields, being able to monitor the field conditions in real time and making that monitoring cheaper, being able to tell you where is there a lot of pests in the field or what might the yield predictions be for this season? I feel like that's a super promising use in agriculture. Not that's something that's really cool that I've seen other people in AI leaf work on. In terms of forestry, I think like computer vision is just such a valuable tool just for helping us get better estimates of carbon stocks, for helping us improve the carbon intake in forests and seeing like where trees might be migrating due to climate change. And it's like it's just impossible given the amount of land that forests cover to survey everything. Having these forecasting models that can give us baselines and benchmarks that people can then go out and verify and we can compare them against it. I think it's just such a valuable tool and it's going to really help with like and the other thing I think is with a lot of these monitoring tools, they can also be helpful on the scale of like natural disasters, natural catastrophes. When you have a wildfire and you find that, okay, now the conditions of this forest have changed really rapidly. And if I fly a drone over this, this is what the area of the forest looks like now. Is there another area of the world that has experienced such an event with similar conditions that we could draw upon, that we could do transfer learning upon, and have a model that can tell you, this is potentially what might shift in the forest moving on. This is the invasive species that you might have to look out for. And this is what might happen to your carbon stock and inform kind of management decisions that way. I think that's also a really valuable use in forestry. Yeah. So, what inspired you to work at the intersection of AI and environmental science? In college, I did a double major in environmental studies and computer science. I felt there was a lot of opportunities for intersections between the two. And also, additionally, I feel like there's not that much communication between the two fields. Like computational biology is a huge field, but computational ecology is much, much smaller for good reason because there can be some takeover when computer scientists get into other domains, like, yeah, perhaps relying too much upon traditional algorithmic methods, not taking into account domain knowledge enough. The intersection between the field when I was in my undergrad, I felt like there was just so much space to utilize computer science tools to help with the prediction and the monitoring for so many environmental problems. There is a great wealth of environmental data out there, not just from satellite imagery, but like from citizen scientists, for instance. And it is very difficult to like analyze these or like scan samples and go through them one by one. There is so much opportunity for intersection between the two. I was in an entomology class. There is a site actually where people will put their own like entomology finds and insect finds on the site and then you can ask people to verify if you classified this insect right or whatever. And there's some people on there who are so good at it. It's very difficult. I found it very difficult. If you put it under the microscope, you have to look at the striation on the wings and you have to look at all these little things. And some people can just instantly get it like that. This website is also a really cool application for a computer science project here. You can make a tracker to help just categorize where people are seeing these rare species and which identifications might be real or fake. So I remember that being like the one of the first times when I was thinking, okay, there's like a really cool application to be had here that I don't think people are quite making that yet. Yeah. So where do you see the biggest research gaps or opportunities in the next 5 to 10 years? Um, Obviously, interdisciplinary work I think is going to be super important in terms of computer vision, particularly, and trying to develop a geographic foundation model, whether that's a foundation model in the vision language domain or just a pure computer vision geographic foundation model. I think those two are like really huge research opportunities. And you can already see like there's so many companies investing into that field. Like Google has come out with a model, there's Prithvi from IBM, another big company with like a model called Climate X, which is supposed to be a foundation model for climate prediction. I don't think any of those models are like go-to foundation models yet, but I think people are really trying to get there. And particularly, I think what's going to be really valuable is having models that are more flexible. So I think like right now, as someone who's tried to apply them, one of the biggest difficulties is the data layers that they intake are not that flexible. And whatever domain you're working with, you're going to have to take some adaptation. Oh, I want to incorporate climate data into this. Oh, I have like this like human population layer that I want to move into this. Oh, I have graph data, vector data, like it's not all rasterized, or like I have some language that I want to put into this. I think like having some multimodal geographic foundation model is going to be so powerful for climate applications. It's going to be so powerful for agriculture applications, forestry applications. It can just give you like a really like good starting point, and then you can do, you know, any number of downstream tasks that you want to do with that. So I definitely see that in terms of the intersection between environmental sciences and the AI field. I see that as like one of the biggest gaps, one of the probably biggest fields where there's a lot of push for development. Um, yeah.